Hi, so welcome. Today we want to, in this video, have the look at how we export our rig out of Spine and get it into Unity and how to switch the animations in there. And for that, I already have Spine open here. I click the Start button, wait for the application to start. And here I just double click on to the um, onto the character I want to export. Just have a short look. I have the jump already split up into a begin and a landing, and I have a lot of animations. But yeah, let's have a look on how to export this for Unity. It's quite straightforward actually. Up here, you go on to export, and we want to have it as a JSON export format. For now, yeah, I'll just select this folder to export into, have it as a JSON. This is all fine, but I want to open the pack settings. In here, what I want to make sure is that I have pre-multiply alpha on. That's all right. And here in the options, where it says .atlas.txt, for you it might be in there like that, just saying .atlas. We need the .txt there for Unity to be able to just read this. So there we click on OK, and that's basically all it. And we are done. That's all we needed. Next step is to go in our file explorer to where we actually now created this. So I'll open up the correct folder, which in my case is here, in here, and now lecturer, 2DGA, assets, and more. And I have now these three files, a TXT file, a PNG file, and a JSON. And that's basically all that we need exported from Spine and then use in Unity. So let's hop back into Unity. And here we are. And first thing we need to do is install the Spine Unity runtime. And I'm doing that via Git. How to do that is you can also find here on the Esoteric Software webpage. Here tells you what packages to install in the package manager and how to do that. But I will also show you right now by just copying this Git package here and adding this to my game by going to the package manager. Now this is open, and here we can see what we can add. Up here next to the plus, click on the drop down, go to the add package from git URL and post the git URL of the package you want to install, and just wait for it to download and install the package. Okay, that took a few seconds, but we're back and we're gonna continue with the next one. So we already got this one, the Spine C#. Next thing we need is the Spine Unity. Copy that, go back into here, and once more, drop down, add package from git URL, and add. And we wait until this one is installed as well. Okay, we're back. And since we're using EuroP, a last one that we want, this time for this web page, where it says Spine Unity download, so not in the installation, the Unity, the EuroP shaders package. Just copy that, go back to the Unity package manager, and also add this git URL. Okay, and with that, all the dependencies we need for today should be installed. So we can close this again and now have a look where we want to get, where we want to import our animation. And for that, I will here create a folder, which I call Momo, the same as the file. And then look for my files here and drag and drop all those 3 files that we have into the Unity editor. And if everything worked out, it should create those extra files. So we now also have like the skeleton data file, the material, and all of those things, which are all the data that we need. And now what we can do is, I will take away those things. We have the visuals for our player, which we no longer need, but instead I will just drag and drop the skeleton data component here into our player as well. Then I open it, and then it asks me what kind of animation I want. I want the skeleton animation one, and now we are here having a huge player component, which I will at first now just reset its position to be at 0, 0. So it looks a bit weird, it's very big, but we will fix that immediately. You can see this warning here that we need to change some settings. And to do that, what we just need to do is change how the color space works. So we go to the project settings, and in player, go to other settings, where it says color space, which is currently set to linear, but for this to work, we need to change it to gamma. So we just click on gamma, change it, and wait, and now the asset actually looks how we would want it to look. Okay, but it's still pretty big, and it is still positioned somewhere where I don't want it to be. So first I'll do is I'll scale it down. Let me click this button to link all the scales together first, and I will scale down, check on the player with the capsule for reference as well. So I see, this is still a bit big. Go back to here and scale it down even more. We'll probably need something like 0.7, 0.06. You have to check a bit with that, go back and forth. Now this is a little bit too small, so I will make it bigger again. But maybe if we go for 0.1, now this is the ground detector here, and so this looks all right. Our visuals are a bit bigger than the actual physics object, but for games that's usually fine. And we have the component in there. So let's just have a look how this looks if we just play the game for now. So I press the start button again, and we're here. You can see our asset is imported, but we can't really see too much. It's not animated or anything. So let's fix this for now. And the first thing I want to fix is, to me, this was a little bit too far away. So I want to actually change the size of the camera. So let's go to the virtual camera and change the auto size. Let's hope that it improved it. Yes, we're zoomed in and we can see a bit more what is happening. Okay, so first thing I now want to do is I want to actually set a default animation. And to do that, we just click onto the spine game object, onto the skeleton. And here we can switch an animation that we just start the scene with. So I will select an idle animation for now, which is the idle side animation. And that means it should already start in that animation. And we now have a, pretty interesting game, but it already works. Okay, so the next thing we want to do is in our movement script, we want, depending on how we move, show different animations. And so we will open up our movement script. I'll open up it in Rider, and then we will adapt how this works. Of course, I trust my solution. Okay, so the first thing we want to do in our script now is we want to also have access to the skeleton and animation. And to do that, we just follow the same structure or same pattern that we used with the rigid body 2D. So here we can now add a private skeleton animation, the one from Spline Unity. Call it skeleton animation. And we want to assign this in the start function as well, same as we assigned the rigid body. So I say skeleton animation equals get component and get the skeleton animation component. So this during the start function, so before the first frame, this object will look for a component called skeleton animation, and then we will get that one. And now let's make sure in code that we also set the correct animation in code, which in my case is called the idle side. So I can get the skeleton animation. On there is an animation state that we can get with state. And with set animation, we can set which animation we want to play currently. So we'll start with the index 0. If you look into the documentation, you can do a lot of things with the different animation tracks, but for our course, it's enough if you set everything onto animation 0. Then next we use the animation name. To get the animation name, you can go to your component here. Probably will complain now that my code is not correct right now. And here in the animations names, we can see we have idle side. Right, now set this to none, and I would not be playing anything. But here I select the idle side animation, and the last one is if we should loop. Yes, we should loop for our idle animation. And now our start function does set it, the animation that we want from code. So let's go back to our game and play it. And let's have a look that it indeed does set the animation correctly. And it does not, since why doesn't it do that? Because get component does not work in the way that we are using it right now, because it's actually not the component of itself, but the visuals are a child. So we can't do it in the same way as here. Sorry for that. Let's change it to use a serializable field. Come on, give me back my stuff. And instead of doing this here, we just set it in the editor. So save your script. Serialize field makes it so that you can set those components in editor. And in our case, also means that we can set the skeleton animation component here by clicking on it. It will show you which ones exist. And now let's play the animation. And you can see we already start with an idle animation to the side, same as before. So you could say nothing changed. What was this for? But now we know that we can set those animations in code. And the next thing that we want to do is now switch to a running animation whenever we are moving. So it's like a short question. When is it that we're moving? And for our game right now, one of the indicators how we can check it is when this function gets called, the movement input switches. So, and when this value here, this float, is not 0, then we're moving, and if it is 0, we are idle. So I will use this one and add a function here. I've added some logic here to determine if we should play the running animation or the idle animation. So what I can do is here check if current movement input not equals to 0. So if it is not 0, then we should be moving, right? So then I say skeleton animation dot state dot set animation still on the index 0, and I think the animation is called run. Let me check that again. Let's go back to our script, to Unity, and check on our spine object if that animation is actually called run. Yes, it is called run. And something funny that will happen now if I play the game is we start in idle. So currently idle, and once we're moving, we are using the run animation. But if I stop moving, we stay in the run animation. That is because we only check if we should switch to run, but we never check if we should switch to idle again. So let's change the script to do that a bit. So else, let's do an else case here. When meaning it is 0, we should actually be idle again. So I set the animation index onto idle side again. Yep, that's the correct name. And loop again. And if we have a look at that, we should be now only moving when we're moving, and otherwise we are idle. So you can see around, and then, oh no, the next problem. We're only ever looking into the right direction, but we switch between idle and running already. So let's fix that we look into the correct direction. And to do that, there's something funny we can do. We can actually use the scale to turn around our current sprites, our skeleton animation. And to do that, what I want to do is first tidy up here a little bit, keep this up here. At the start, I want to take a snapshot of the current scale transform. So I know that is a vector 3, and I call it start scale. And so that I don't have to set it here, I will just get it at start as well. So at start, I say start scale equals transform dot local scale. So that means I want to know what scale I currently have in the start. Now in here, I know here the input is 0, and here the input is not 0. So I can check if the input that I currently have, so if current movement input is bigger than 0, meaning it's positive, we set the local scale that we have to the start scale. That means we just want to show it as we showed it before. Else, meaning it's below that, what I will do is now I'll flip one of those things by creating new vector 3, which is start scale.x, but -1, and now start scale.y and start scale.z. Meaning I will flip around whenever the value goes above or below 0. So let's have a look if that worked. And you can see we can go left and right, but I seem to have a small mistake in my code. Can we find my code? Start scale, and here it is vector 3 start scale x. Nope. Let me have a look. I'll show you immediately. Okay, yeah. The problem is, of course, I don't want to change the transform of our player movement itself, but actually the one of the skeleton animation. So down here, let's do it a little bit lower as well. So the start scale is actually the skeleton animation.transform.local scale. And now every time we need to change that, we need to make sure that we actually change the skeleton animation local scale. And now this should be working. And still not correct. Okay, and of course, if we actually put this into the correct clause here, meaning this one, it might actually work. Right now, it was only on the idle state, and that's not actually where we want this to happen. We want this to happen, of course, in the run state, this change. But yeah, now it works. So you can see I can move left and right, and that's it. So keep in mind, I also make mistakes, but it's fine. So if current movement input is not 0, meaning we are running, we switch to running, and now we also switch the scale that we are looking at in the case that we want to change that. Amazing. Now, that's basically all you need to do for the assignment. But of course, it would also be great if we would have a jumping animation. And to do that, I will now show you how to also more or less play a one-shot animation, which we can do here. In our case, we will do the exit ground. So now in exit ground, I don't only want to set is grounded to false, but also want to set the animation. So here I just say skeleton animation dot state dot set animation, and we have a jump begin animation. So I want to say here jump begin is the animation I want to play, and this time instead of making it a loop, I just want this animation to play once. So let's go back to our game, play the game, and have a look on what happened now. So running left and right, still the same, but if I jump, you can see we jump, and then there's some weird stuff going on. Now, what do we do next? We exit, but we never go back to the jump end animation. So the next thing is that I want to do is when we're entering the ground, I want to play the enter ground animation. So state here, set, and that part I called jump end. And I also don't want to loop that one because it's just a normal animation. Right. So let's have a look at how our game behaves now. I hope a little bit better. So we can move to the right, to the light, and here's an error. It's not called jump end. What is the actual name? It's called jump landing. So let's change it. Not jump end, jump landing. Okay. And you can see now I can run, I can jump, and I can even land, but afterwards I keep on sliding. And we can also do it in the other direction. But game already got a little bit better. So what's the next thing we could do? We could say, right, when we enter the ground and this animation is done, we probably want to either we want to either like run or be on the idle animation again, right? So what we don't want is we don't want to stay in the landing animation. So okay, so if we want to add an animation to play right after another animation, we can simply do that by using the add animation function. Add animation function looks very similar to the set animation function, but if I set here 0, run, and now true, because I want it to loop, we're still missing a last one, and that one is the delay until this one should play, and I will set this right to 0. So we can have a look at our game now. So if I run, I jump, I go back, and I can also continue to run. But there's this one little problem. Right now, at the end of our animation, if we're not moving, it still goes to the run animation. So we should think about how we can handle that. So what we can do is actually we need to check if an animation ended and what animation it was, and to discern what we want to do. And for that, I will just write an await function where I want to set up all these handling things. So if we go, actually no, actually I want to, yeah. If we go here and we look at the skeleton animation at state, you can see that we have a lot of things here, and some of them are events. And there's also this complete event and the end event. So we can use the complete event, which is always then called whenever an animation is complete, to add a function that is called whenever this is an animation is complete. And I want to add a function which I will just call private void determine animation after landing. And this one takes a track entry. So it's a track entry here. And I can now add this one here to the state complete. And I'll say, okay, I want to call the function determine animation after landing here. Now in here, I can check in the entry, in the animation, the name of the animation. And I only want this function to do something if the animation name was my landing animation, which I called jump landing. So if this name is not jump landing, no equals, no plus, and here we use the correct quotes. So if it does not equal jump landing, we will simply return. Don't do anything. So, but if it is jump landing, meaning we don't go into the early return that we have here, I now want to determine, should I be moving or should I be idling? And to do that, we already know how we can check that, because we just need to check if the current movement input is 0, or if not, all of those things that we have above there, right? So I just need to check if current movement input not equals 0, then I want to set the skeleton animation state, set animation to be run. Still looping. And else I'll just set it to idle side. And now let's have a look if that worked. Still compiling, no compiler errors, always a good sign. And back into here, and I jump, and we can see it also goes into this back, but if we run, we run. So that might have been a lot at once, so let's have a look what we do here. In the await function, we already have like the skeleton animation, and here we know there's a complete event which gets fired every time an animation completes. So we add a function here that we want to call every time that happens. And in this function, we check if the animation that was currently playing has the name of jump landing. If it doesn't early return, it's called a guard clause. If it is jump landing, so we don't go in there, we just continue. Check, are we currently moving or not? If we're moving, next animation is run animation, else the next animation is the side animation. Also means we can get rid of this add animation down here because that is no longer relevant. So let's play around with it a little bit more, but that should be basically it. I can jump, it goes down, I can land. And that's how we can, just with a little bit of code, already have an interactive character controller. For your final project, feel free to look into the documentation, have play around a little bit. There's also very cool ways how you can mix animations, interpolate from one animation to the other animation. But I hope that this short recap gives you all the things that you need to make your spine animation come to life in a Unity game. And for that, I will see you probably and hopefully in the next video.